join us. All right. Can everyone see my screen?
Yes, sir.
Yes, sir.
All right. So I'm not sure if you guys handled functions at your schools, but this is supposed to be on paper one as well. Did you guys do anything related to functions at schools?
Yes, sir.
Okay. So here we are given a question. We are told that sketched below are the graphs of f at x, which is given as 2x minus 4, and g at x, which is given as a x squared minus q. And then we're also given h at x, which is given as mx plus c. So we have three graphs in total. F is a straight line, g, it has that squared over there, so it's this parabola over here. And then h, it's this line over here. So as you can see, next to the line, there is some letter identifying which is which, like that. Right. So firstly, we are asked, before starting with the questions, let's finish that statement. So we are told that A and B are the x-intercepts. So there is A and there's B. Those are the x-intercepts, as well as C is the turning point of G. So C is over here, and it's the turning point of G. We're also told that B, the x-intercept, and C is the y-intercept of F. So this line over here, like that. And then we're told that A is the x-intercept, and D is the y-intercept of H. So here they're just indicating that this point is an x-intercept for this graph and that graph and so on. Right. So firstly, we are asked to find the equation of G. So equation of G, it's the one for this parabola over here. So let's write the equations that we have. So it's f at x, it's equals to 2x minus 4. And we also have g at x, which is a x squared minus q. So remember, let's just change this color over here. This q value is your y, okay, in this case it will be your y-intercept, but it's just telling us from the original graph, which is like this, how many units did this graph shift by, whether it's upwards or downwards. So since this point is being shared by f and this graph over here, it means that for point C, the coordinate of C is 0 and -4. So I get this -4 from this. So here I can say for coordinates of C, to get the coordinate of C, since it's the y-intercept, I can let my x value to be 0. So this would be y, it's equals to 2x minus 4, like that. And then wherever I'm going to see x, I'm going to plug in 0. So it will be y, it's equals to 2 into 0 minus 4. And then this ends up being y, it's equals to -4. So hence we can say that this coordinate over here is 0 and -4. So for this part, we can say g is now g at x, it's equals to a into x squared and this -4 over here, like that. Let's just put it like that. All right. Next, we are supposed to find this value of a. Let's see another coordinate that we can get. So for coordinate b over here, it's on f, and for f, the equation of f, we have it completely. So we can find this. This is the x-intercept of f. So we can say x-intercept, you let y to be 0. So it will be y, it's equals to 2x minus 4. Wherever I'm going to see y, I'm going to plug in 0. 0, it's equals to 2x minus 4, like that. And then I end up with 4, it's equals to 2x I divide by 2 both sides, end up with x, it's equals to 2. So that means the coordinate for b over here, it's 2 and 0, like that, right? So here we can just say substitute the coordinate of b, which is 2 and 0, into g. So that means where remember this part, it's just your x value. This is x and this is y. So this will be where you see y. Remember the letters, whether it's g at x, y, all of these things mean the same thing. So g at x and y are the same thing. So g at x is the same thing as y. It's equals to a into 2 squared minus 4, like that. So we're just solving for a now. And then we have 0, it's equals to 4a minus 4. So 2 squared, we get this 4 over here. We take this 4 to the other side, we have a, we have this. Divide by 4 both sides. So we end up with a, it's equals to 1. Therefore, we can say the equation of g at x, it's equals to x squared minus 4, like that. So remember the 1 is here, but we don't write it. We just know that there's a coefficient of 1 over there. Any questions regarding that one? Any questions?
Oh, yeah.
All right. So this is for 3 marks. So they are assuming that you are able to detect, to get this value without calculating for it. And this one, you have to calculate it. So you might get maybe a mark here, and then you might get 2 marks somewhere here, like that. So that's your 3 marks for this question. All right.
Sir,
Yeah.
I said into the so maybe exam is consist out of how many marks?
This is an exam. This is from an exam.
Oh.
This is from an exam. Where's that question paper? This is from an exam. This was a June paper, actually. June paper 2019. So you'd have first have some algebra over here, more algebra, patterns. I think this is for last term for you guys. And then you'd have this. So this is in an exam.
So mangapasa zonke lezi zinto lezi and then ama-functions ngawayeka.
Why would you leave them out?
Too difficult.
All right, let's see if by the end of this you'd be understanding something.
Yes,
All
sir.
right, do you understand what we have done so far?
Yes, sir.
All right, let's continue.
Sir,
Mm-hmm.
is this session recorded?
Yeah.
All right.
All right. So from here, it's 2 and 0, 0 and negative 4. Okay, so moving on, just needed to remember these coordinates. This we said it's 2 and 0. This is 0 and negative 4. For g at x, we ended up with x squared minus 4. All right. So here we are told that we are supposed to show the equation of h is this, if the length of CD is equals to that. So CD, this is C, and that's D over there. So if here we know that this is this coordinate over here is negative 4, this coordinate it will be 0, and we just need to be able to count from here to there. That's it. So we're just counting 5 units. So from negative 4, you have negative 3, you have negative 2, you have negative 1, you have 0, you have 1, you have 2, and so on. So starting here, that means this will be 1, 2, 3, 4, 5. So counting 5 units, it means that this will be 0 and 1. We are moving to the right because here we're moving upwards. So we are moving to the positive numbers. So this coordinate over here, which is the coordinate of D, I think, that's 0 and 1 like that. Any questions regarding that one? Any questions there?
No, sir.
All right, so just did a simple count here. So remember, we are still trying to find out the equation of h at x. So far what we know for the equation of h at x, we only know the y-intercept of that line. So let's write that down. So the equation of h at x, it's equals to, we're told it's mx plus c. So right now we just found out that this coordinate over here, which is the y-intercept. So the y-intercept is your c value. So this will be plus 1 like that. So now we need to find out this value, which is our gradient. To do that, we need to find a value or a coordinate that we can substitute, whereby we know the y value and the x value. Right. So we're checking this line over here. That's our h. What's this? H line. So to do that, remember this point is being shared by G as well as H. So that means if we can find the x-intercepts of this line, remember x-intercepts are where we cut or pass through the x-axis. So if we can find the x-intercepts of this line, it will give us this point as well as that point. But we already know this point, so that means the other one will be the one that we're looking for. So this will give us two values. We are only looking for the other value. So we'll say g at x over here, it's equals to x squared minus 4. We are looking for the x-intercept. So you let your y value to be 0. So here to be 0, it's equals to x squared minus 4 like that. So this, remember, it's your difference of two squares. So you can just open two brackets like that. And then you'd have x and x, 2 and 2, plus and minus. So your x value is equals to minus 2, or your x is equals to positive 2, right? So if you check this coordinate over here, the b coordinate over here already used up x as the as 2. That means we will say a is the other value over here. So coordinate of a is minus 2 and 0 over there. This is D, this is A. Minus 2 and 0. Any questions regarding that one?
No, sir.
All right, so remember what we were doing here. All of this was just for us to get a coordinate that we can be able to substitute back here. Right, so let's see if that worked. So we'll say sub A into h at x. So our h at x is mx plus 1. So that means where I'm going to see y, I'm going to plug in 0. Where I'm going to see x, I'm going to plug in minus 2. So it should be 0. It's equals to m into minus 2 plus 1 like that. And then I can take this minus 1 to the other side, becomes minus 1. I have minus 2m. I'm looking for m. I can divide by minus 2 both sides. Like that, I end up getting that my m value, it's equals to 1 over 2. So it will be positive 1 over 2 because that negative and that negative will cancel out. Right. So now we can write our final equation for h at x, which is h at x, it's equals to m, which is 1 over 2, x plus 1. So we were able to show that this is true like that. So the first trick was for you to understand that for you to get this coordinate, you just need to count from -4, count 5 units upwards, and then get that coordinate over there. Next, to get this point over here, you just needed to use the equation of g at x, using g at x to get this intercept. So x-intercept, you got 2, you got this one and that one. But remember, this one we already know which is this x equals to 2. The other one is there, x equals to -2 value right here. So if you are suggesting that here you could have used, maybe you could have said x squared is equals to 4 and then apply your square root over here. Just have to remember that when you apply the square root, it's plus minus. So that means this will end up being x is equals to 2 or x is equals to -2, and then you choose the right value that you're looking for. So if you're going to apply the square root without the plus minus, that means you'll only get this value. It might be, it won't be correct because this value you already know, this is the other value that you're looking for. So that means you won't get that question correct. Any questions regarding that one?
No, sir.
All right. Let's see. They're asking us to find the coordinates of E, which is the point of intersection of F and H, like that. So let's erase here. So now we know the equations of F. So F at X, it's equals to 2x minus 4. And H at X, it's equals to 1 over 2x plus 1. So they are asking us to find the coordinates of E. E is over here. Point of intersection, that's where the two lines or the two graphs meet, right? So where those two lines or two graphs meet, they have the same coordinate. So the coordinate is the same. That means the y value of this guy, y value of F is the same as the y value of H. So we can say E is a point where f at x is equals to not g at x, but h at x, like that. So remember, this is still the y coordinate, So that y coordinate is the same as this y coordinate. And then from there, we just plug in the equations. So for f at x, I'm having 2x minus 4. For h at x, I'm having 1 over 2x plus 1. Then from here, I'm just going to solve for x. So I have 2x minus 1 over 2x is equals to 1 plus 4. So this is supposed to give me, let me see, I think this is 5 over 2x. It's equals to 5, like that. So I'm trying to get rid of this 5 over 2. I can multiply by 2 over 5, both sides, like that. So I end up with x, it's equals to 2 over here. Let's see, is that even correct? It's supposed to be. All right. Can we confirm this part? It's supposed to be 3, not 5, sorry. This is 3, not 5. So it's 3 over 2. That means here we're multiplying by 2 over 3. Here it's over 3 as well. All right. That was messed up. So this is going to give us, I think, 10 over 3, like that. 10 over 3 is 3 comma something. So if this is 2, this can be 3 point something something. So that means that coordinate is fine. So we only have the x value of that coordinate. We are looking for the full coordinates of E. We need the x value and the y value. So we do have the x value. To get the y value, we just take this x value that we got, we substitute into either equation. So we can say y it's equals to, if we substitute back to f, 10 over 3 minus 4, like that, then our y value would just be whatever this is going to give us. So I'm thinking it's going to be 20 over 3 minus 4, which is 12 over 3. And I'm thinking this is just going to be y it's equals to 8 over 3. Right. So you can verify the calculations on your side. I'm just trying to do them quickly here by head. So the coordinate of E, we have to write it fully. You can say the coordinate of E, it's going to be 10 over 3 and 8 over 3, like that. Any questions on that one? Any questions?
No, sir.
No, sir.
All right. Following question. Let's just do this.
No, sir.
The next question is asking us to write down the range of G. So the range, these are the Y values for which the graph exists. So range, we are only looking at the Y values for which the graph exists. So if I'm gonna get something like this, let's just say a graph like this for fun. And then we are told that the turning point over here, maybe it's at 1. For this graph over here, the range of it, it's from 1 going to wherever it ends. So it's from 1 up to positive infinity. So this becomes the range of this graph. If it was somewhere here, wherever that turning point is going to be, if it's -2 over here, that means it was going to be from negative infinity, from down there, up to -2, like that. So this would be the range of this graph. Do we understand what the range is? So we're only looking at the Y values for which the graph exists. So the graph is not found anywhere here for this green graph. We don't have it here. So we cannot say these values over here are part of the range. So it's from negative infinity, wherever negative infinity is, up to up to the turning point over here, or up to this line, which is 2 in this case. Does that part make sense?
Yes, sir.
And the domain will be the X values for which the graph exists. So domain, this becomes the X values for which the graph or function exists. So here you're looking at only the X values. So still, if your graph, let me see, which one can I think of that has issues with domains? Maybe let's say your graph, it's only from here up to there. That means up to negative infinity. That means your graph does not exist. If you are told that your graph ends here, it doesn't exist this side. That means we can say it's from negative infinity up to 0, like that. So we are saying we're using a square bracket because they've shaded that point over there. If it was an open circle, then we're gonna use a curved bracket like that. So those are we're looking at only the X values for which the graph exists. We don't care about the Y values. That's the domain. So now if we check our graph here, we are asked to find the range of G. G is this graph over here, like that. So we know the value of the turning point was at this line, which was -4 and 0 over here. This coordinate over here, it's -4 and 0. So this line becomes where the graph ends. So you don't find the graph anywhere down here. So from the turning point going up, that's where you'll find the graph. So you will say your range is Y, such that Y is an element. There's an E that we write just to say element. Y is an element of, so it starts from -4 up to positive infinity. We don't know where it ends. So it starts from -4. So -4 is included because it's part of the turning point. From -4 up to positive infinity, like that. We do not include positive infinity. We do not use a square bracket for positive infinity because we do not know the exact number that we can say this is positive infinity. So it could be a million, could be 10 million. So we are not sure which one of those was used for infinity, like that. So this is your range. So that's that 1 mark over there. Just go to the turning point, check is your graph above or below the turning point. If it was below the turning point, if your graph was like this, if your graph was here, that means from the turning point over there going down. So this was -4. So we'd say our y is an element of, it starts from negative infinity down there. It starts from negative infinity. So negative infinity is also a round bracket because we don't know the value of negative infinity. And then it ends at -4. But -4 is a square bracket. So the order of these numbers matter. This is the starting point, and this is the end point. Starting point from negative infinity up to the end point, which is -4, like that. Any questions regarding range?
No, sir.
All right. So the range of this one is just from -4 up to positive infinity. Right. So the tricky questions become this one, but it's not tricky after explaining it. We are asked for which values of x is f at x greater or equal to g at x. So what they are saying here, f at x and g at x. So g at x is this guy. F at x is, I think, this line over here. So we are asking ourselves, where is the straight line above? It's greater than, remember, this part is greater than, the point is larger compared to this small point over here. So where is f at x above g at x? So if we check our graph over here, for where f is above g, so f is over here and g is below here. So that only happens in this section from this point, from the turning point up to that point. That's the only section whereby we find out that f is above g. So this part, f is above and g is below. If we check from this point going that side, this is g. G is above and f is below, like that. From this point going that side, f is below, g is above, like that. So we are only asked to find this part, this section over here. So this section for x values, this, remember, is x being 0. This we calculated as x being 2. So the only section whereby we have f at x being greater than g at x or being above g at x is from 0 up to 2, like that. But they said greater and equal to. So these at this point and that point, they are equal. That means we can say now like that. We can put those equal signs. So 0 is included and 2 is also included. So this becomes our answer. 0, x has to be greater or equals to 0, but less or equal to 2, like that. And then if you want to flex, you can say that your x value has to be an element of real numbers, like that. So we are saying real numbers. That means this could be 0.5, it could be 1.3, it could be what. So all of those values will always ensure that this graph is above the the G graph. Does that one make sense?
Yes, sir.
So if the question was, for which values of x does f at x less and equals to g at x, like that, That means we were gonna check now the sections where the parabola is above the straight line. So if we check from here, going that side, the parabola is above and then the straight line is below, like that. So that means we would say something like your x value has to be less and equals to 0. So remember, from here going that side, those values are less than 0. Or starting from here, going that side, you would be having the parabola being greater or above the straight line. So or x has to be greater or equals to 2, like that. So your question could have been phrased in this way, and this is how you were supposed to answer it. Any questions on that one?
No, sir.
If there are no questions or any other questions, we can end the session here and people can continue studying on their own. People can continue studying on their own. Thanks for joining in. Bye-bye if no one has a question.
Sure, sir.
Sure.
Oh.